So the last thing we talked about with DevOps is ways to be nice to the database. And recall, one of the reasons we want to be nice to the database is that it is the most tricky of the three tiers in the three-tier architecture to scale out, right? Unlike the application tier and the web server tier, you can't just sort of add copies of the database and hope that the right thing will happen. So the best thing you can do is use wisely the database capacities you do have. We talked about indices as one way of doing that. We've talked about caching as a way to reduce both computation time and the load on the database. And one more technique that we're going to talk about is accidentally abusing the database with too many queries. So this is called the N+1 query problem. And in a minute, you'll see why. Here's a little hypothetical bit of code we might add to Rotten Potatoes if we had a view where we were going to list for a subset of moviegoers their name and then all the movies that each one of them likes. Probably we can imagine setting this up as a typical has many association. A review is linked to a moviegoer and is linked to a movie. And so if you have a moviegoer and you want to find out which movies they like, you have to traverse the reviews association, right? We sort of saw how to do that when we talked about indices and caching of foreign keys. So you might have in your controller, you might have a variable that gets set to, some subset of moviegoers, doesn't really matter which ones. And then you think, okay, easy enough. In your view, you just iterate over all of those moviegoers. And for each one of them, you're going to look at the movies, you're going to list the movies that they have written reviews for. So here's the subtle problem with doing this. Remember we talked about how active record queries actually get done as late as possible. So really, even though up here, we've got an active record query for a moviegoer, the actual database hit doesn't happen until we try to do something to materialize the result, right? And in that case, it's when we're rendering the view. As soon as we hit this each, now the query is forced to happen. Okay, so we do a query and we get all these moviegoers. The problem is that now when we're inside this loop, and for each moviegoer we want to get their movies, each time through the loop, we're doing another database query because we have to get the movies that are associated with that ID. In other words, as we traverse the association. So this is why it's called the N+1 query problem, because you're doing one query up here to get sort of the outer part of the join. And now inside the loop, each time through, you're doing another query. And this is kind of foolish because the truth is we know at the very beginning of all this that not only do we want the list of certain moviegoers, we know already that for each one of those, we are also going to want a list of all their movies. So it seems like there should be a way to save some of this work. So indeed, the easy way to do this is instead of this sort of straightforward moviegoer query, Rails allows us to do this, right? So what this means is moviegoer has some sort of an association that will allow us to figure out movies, right? And indeed it does, because we've declared that a moviegoer has many movies through reviews. So Rails knows how to construct a join query that will traverse that association through the reviews table. What this is saying is when you do the moviegoer query, even though the thing that we're going to get back behaves like an enumerable of moviegoers, the query has also included all of the join information from the movies table. And that means that we don't have to change the code in our view, but now when the moviegoer query happens here, it is also preloading all of the information that would result from traversing that join association. And now there are 0 additional queries in the inner loop. So instead of doing N+1 queries, you're doing one query, right? And it's true that that one query is now going to return a lot more data, but databases are really good at that, right? So the overhead that you save by not doing the N queries in the inner loop is more than worth the extra cost of preloading all of that data, essentially doing the outermost query. Now, of course, if it turns out that you later change your code and now in the view, you're no longer listing the movies, you're just listing the fans, now you've sort of done needless work, right? So now you've done a moviegoer query that is going to include all the joined movies, but you never actually end up using them for anything. This is not the end of the world. There's a number of different Ruby gems that actually run and sort of add a little pane to the bottom of your main window. And they're actually showing you places where if you did an include clause, you could avoid an N+1 query. But it also will show you cases where you're doing the include, but then you're never using the result. So you're sort of wasting the effort of doing the N+1 query. But the bigger lesson here, and again, we've said this many times, we're going to continue to say it, all abstractions eventually leak, right? In this case, the abstraction originally was that you could just do your first query over moviegoers and then obliviously grab all the movies for each moviegoer. In fact, if you do it that naive way, you will do a whole bunch of needless queries. So to fix the problem requires you to understand that even though the abstraction is it's a has many relationship, In real life, it's implemented by doing table queries. And so knowing something about the implementation puts you in a position to avoid sort of needlessly inefficient implementation. So that's the N+1 query problem. And again, what's relevant from our point of view is not memorizing how you do this, right? It's internalizing the idea that whenever you're using an abstraction, you should be wary. All abstractions are imperfect, and knowing something about how the abstraction actually works can better prepare you to avoid misusing the abstraction by accident.